So our next question is showing over there, and as you can see on the screen, it's what? Rotate the area between y equal to x and then y equal to square root of x from the boundaries, which is x equal to 0 to x equal to 1 around the x-axis. So our previous question, we were rotating only one function, that is y equal to square root of x. But in this question, we are rotating our two functions. That means we have to do a simple hand sketch for these two functions, and then we proceed with the revolution, right? So for this type of question, note that we are revolving around that same x-axis, that is what y equal to 0. So for this type of question where you have to do a simple hand sketch for what? Your two functions, this is what you can do. The first thing that you can do is to find what? The point at which the two functions are what? Meeting, right? But we are lucky. Some questions are there, they will not give you all the boundaries, but for this question we have been given the boundaries, and therefore there's no need for us to find the meeting points, right? So in such cases we don't have to find the meeting point. But in cases whereby we are not given the boundaries, which is x equal to 0 and x equal to 1, that means that we have to find out the boundaries, or that means the point at which they are meeting. And even this question, you can actually solve it with that what? You can actually solve it with that what? Sketching the graph. To make things simple for us, do you know what we can do? What we can do is to kind of try and make y equal to square root of x to be like y square equal to x. Is that okay? Yes, y square equal to x. So in that case, we'll be able to find some values quickly. So let's quickly look at, we have the function y equal to x over here, and we also have y equal to square root of what? X. Is that okay? So based on that, what we can do is that for this function, let's quickly make it what? X, let's say, equal to y squared. Is that okay? I just found what? Square here and then square here to eliminate the square root. That's what I did, right? So now you have x equal to y squared instead of y equal to square root of x. You can of course do it since y is equal to y, then you can do it x equal to square root of x. You know, mostly I advise students that pass or pick the parts that will make your work easier, right? So in that case, if I look at the question critically, I can say, okay, if I eliminate the square roots and then I make x stand alone, like x equal to y squared, it will make things easy for me. So now I'll get x equal to y squared, and I also get the original question which was there, right, which is y equal to x, or you can do it x equal to what? Y. If I'm trying to find a meeting point, then I can say that, okay, my y equal to what? Y squared, because x is equal to x. Is that okay? So based on that, I can send this one to this side. I'll get y squared minus y equal to 0. So now you can see that y is common inside. So what we can do is that factorize the y out. So I'll get what? Y out, y minus what? 1 equal to 0. That's where we found out that we have y equal to what? 0, and then y minus 1 is equal to what? 0. Therefore y equal to what? 1. Is that okay? So now that we have this, we have y equal to 1. Go and put this y equal to 1 in any of the functions that we have up here, and you'll be able to get its corresponding x value, right? Because we are rotating, remember, we are rotating or revolving around what? The x-axis. We are not dealing with the y. So in that case, we are going to put the y value inside any of the function. You can put it in y equal to x, or you can put it in y equal to square root of what? X. So if you put it here, y equal to 1, then I'll get x equal to 1. When I put it here, y equal to 1, 2, you have the same thing, right? 1 to the power what? Squared, which is equal to x, is the same as what? 1. Is that okay? That's where this limit that we are seeing here, that was given to us in the question, came from, right? So you can see this is simple. So if you are coming to do such things, what you have to do, the first thing that I advise mostly students to do is to kind of find a meeting point. So now we know that the function meets at 2 points, right? The first point will be x value, which is 0, and of course when I put 0 back into the original functions here, I'll always get 0, right? So that means x is 0, and then the y is also 0. Let's say my point is A. Now my point, the next point, which is B, we have x after putting it back into the function, we have x equal to what? 1, and we also have what? Y equal to also 1. So that gives us a fair idea that when we sketch the function, we are going to get the two meeting points, 0 and also 1. So now let's quickly do some sketch, simple hand sketch here. Right? So let me put here and then do this. So now this is what I have. Now since I have this, what do I do? This is what I can do. I know that my 0 is here. This is my y and this is what my x, right? This is my y and this is my x. So what you can do is that we know that the first one will meet at this point, right? The graph will meet at this point, and you know that this part is not what we are talking about, but we know what we have done. We have done this one in the previous question, right? So we know where it's supposed to go, and based on the previous question, it's supposed to be this way, right? Yes, I've already explained. If you have not watched the previous video, please go back and then watch that and come here, right? So now this is what this particular function will be like. And now the next one that I want us to also look at will be this one. So we have y equal to x. Comparing this one with what? An equation of a line, which is y equal to mx plus c, we can see that our gradient is what? M, which is in this case is positive, and here is what? Our y-intercept. Comparing this one to this particular one, we can see that here our gradient is 1, but we have a 0 intercept, right? So in that case, how does a positive gradient line look like? It looks like this way, this one. Have you seen that? Assuming that we have y equal to negative x, it means that our gradient will be negative 1, and what? A negative gradient line behaves like this way. Is that okay? So in that case, we have a fair idea that our function, which is y equal to x, will go this way, right? It will go this way, but not the other way around, like this. No, it's not that. So let me clean it, right? Yes. So now that we know that it has gone here, make sure that let me draw it quickly. I'm thinking, okay, let me put it well, because they are supposed to meet at this point. So when you are drawing, make sure that you meet at that point. So you can see that the two graphs or meet at point 0. So our next meeting point is supposed to be at what? 1. And then of course we know that at this point, let's say the y value is 1. Is that okay? So we are good to go. So now that we are revolving along the x-axis, when we revolve it, it should be symmetrical about the axis of revolution or rotation, right? So in this case, we can have similar. It's like we have turned this figure here down this part, right? So if I'm to turn this one or revolve it along the x-axis, I'm going to get a figure like this, which is symmetrical, like simple. It should be the same thing like the up there, right? It should be the same thing. So now the same thing, yes, and we know the meeting point is this. So now this is what we will have after doing a simple hand sketch and revolving it along the x-axis, right? So last time I was telling you that for this type of question, the only part of this graph that we need to find the volume is this part. These are the part that we need. We are finding the volume. So we are finding the volume towards occupied by the two graphs above what? The x-axis, or the if we are doing in the area form, we can see the area under the two graphs and is above the x-axis. So looking at this, the volume by the two graph above the, and we can see that the volume that these two graphs are occupying simultaneously is this path. It's common. This is a common volume, right? That's the part that we are interested in. So based on that, what can we do? Last time I was telling you that first of all, because we are approximating it in a Dix form, and then we use we are presenting the Dix form. We use the area of what the Dix, and remember the Dix is what? A circular Dix, right? So based on that, we are using the Dix washer form because we are approximating the Dix form first, and then we use the washer approach. So in that case, what we can do here is to find the radius of the outer function and also the radius of the inner function. So here, what is our outer function? The outer function is this. What is our inner function? And the inner function is this. right? So looking at this one, if we are to approximate it at any point to a circular disc, it means that for this point from here to here is the diameter. That means from here to here is what our radius, right? And then our radius, when you put that value, x value there, we are supposed to get a corresponding y value, and that will help us to estimate the radius at that point, right? So for the, let's assume that the outer function has a radius of capital R, right? That is outer. And then the inner has a radius of small r, as I was saying the last time. That is inner. So in that case, for the area of the outer function, let's say AO is going to be giving us pi r and then squared, and then the inner function is going to give us what? Let's say I equal to pi and then small r squared. So if you have something like this, since we are interested in only this part of the function, our total area is going to be A outer minus what? A what? Inner. And that's going to giving us what? A total is going to be giving us what? Pi r squared, right? And then minus pi r squared, small r squared. So in that case, you can bring the pi out, and then we have our r squared minus our r squared. So how do we estimate this? And as I was saying earlier on, we use the function to estimate what? The radius. So in that case, what is the outer function? Our outer function is this one. Is that okay? So in that case, we are going to get pi out. Let me continue this way. So now we are going to get what? Pi out. And then because the outer function here is y equal to square root of x, we are going to get what? Square root of x. And don't forget that it's what? Squared. Minus, now our inner function is x, right? So now we are going to get what? X, and then don't forget that it's squared. So in that case, when you simplify it, we are going to get pi and then x minus what? X squared. So since we have the area, the total area to be this, then we can integrate over this. And don't forget that we have the limit of integration. Even if it is not given to you, based on what we did over here, you should know that the limit of integration should be what? The 0 and then 1, which is the meeting point of the two graphs, right? So based on that, we can say, okay, the integral of 0 to 1, you can decide to bring the pi out, and then we use the expression here, and then we have what? Dx. So now let's go ahead and integrate what we have. So if we are integrating what we have here, we are going to get pi out into bracket. We get what? X squared over what? 2 minus x power 3 over what? 3. And have a limit of integration to be 0 to 1. So now I have pi out here. I'll have 1 over 2, or 1 squared over 2 minus what? 1 to the power 3 over what? 3. I have this one here, right? Or minus 0 squared over 2 minus 0 power 3 over 3, of which we all know that's going to give us 0 at that part for the 0 part. So all this side goes to 0. And we have to only work with this part. And we are going to get pi out 1 over 2 minus what? 1 over 3. And then you know that we have to be equal to pi out. And then LCM to be 6. Right? So we are going to get 3. And then minus, so we are going to get 2. And at the end of the day, we are going to get what? Pi multiplied by 1 over what? 6, which is equal to pi on 6 as our volume. Therefore, we can conclude that the volume of revolution is pi on what? 6 for this particular what? Question. So in solving this type of question where you have to plot the two functions, as I was saying earlier on, there are few things that you have to consider. If you are being given the limit of integration, then you are lucky. If they don't give you the limit of integration, then you have to find it yourself. So how do you find the limit of integration yourself? In doing that, first of all, you need to know where or which points are these two functions meeting. So in that case, we have to equate the two functions, and you have to do it in a way that will make you comfortable. So in that case, you have to rearrange the function to do whatever you want to do. So in doing the arrangement and equating the two functions, you will get what 0 and 0 and also 1 and 1 based on this question, but in other questions you can get a different values for that. So when you do that, then it will help you to plot or sketch the function. When you sketch it, the next thing is to do a sketch of what the revolve function in 2D, like what you are seeing over here. And then when you are done with it, I showed you how you can find out the radius. And when you do the sketching, you know which function is the outer function and which function is what the inner function. And you know that will help you establish the relationship of the radius, and by using the washer method. And after you find the total area, then you integrate over it to find the volume of evolution. So people also kind of have a fixed formula that they use, as I stated earlier in my previous video. You can also use the formula directly, as I said, but this is the fundamental way of doing it. That is kind of helping you to understand where things came from. Yes. So thank you for watching, and see you in my next video.